Today's video is on integration using residues. In today's video, we are going to find out the residues of the function f of z is equal to z square minus 2z by z plus 1 square into z square plus 1. So in order to find the residues, first we have to find the poles. So here the given function is f of z is equal to, this is z square minus 2z by this value is z plus 1 square into z square plus 1. So here I am splitting the z square plus 1 as z minus I into this value is z plus I. Clear? After splitting this denominator, in order to find the poles, what we have to do? We have to equate this denominator to 0. So here, what is the denominator? This is z plus 1 square into z minus 1 into this value is z plus I is equal to 0. First of all, if I equate this one, that is z plus 1 square is equal to 0. So clearly, so z is equal to, the value here is minus 1 for 2 times. So we got a pole of, so this is a pole of order 2. So this is a pole of, this value is order 2. So if I equate z minus I to 0, so we are getting z value as plus I. So here it is a simple pole. So this is a simple pole. And again, if I equate z plus I to 0, I got the z value as minus I, and which is again a simple pole. See here, after finding the poles, we have to find the residues for the corresponding poles. So it's so simple. So I have, see this one resolved into partial. After resolving into partial fractions, I have split this z square plus 1 as z plus I into minus I, and after equating the denominator to 0, so I got the pole values. So this is z is equal to minus 1 is a pole of order 2, and next one z is equal to plus I, and next one z is equal to minus I. These two are simple poles and it is a pole of order 2. Now we have to find the residues. So how we have to find the residues here? So in order to find the residues, first of all, the formula here is, in order to find the residues of the function at the point z is equal to z naught, here the formula is 1 by m minus 1 factorial into limit z tends to z naught d by dz power m minus 1 into z minus, this is z naught power m into f of z. So here m is the order. First of all, in order to find the residue for the function, so which function? F of z, here order value is equal to 2. So m value is equal to 2 and the pole value z naught is equal to minus 1. So for this, if I find the residue, see here, residue of the function at point z is equal to z naught value is minus 1. So m value is the order value, which is nothing but 1 by 2 minus 1 factorial into limit z tends to, the point here is minus 1, and d by dz power, this is 2 minus 1 into z minus, z naught value is minus 1 here. So this will be plus 1 and power m, so this is a square into f of z. So what is our f of z value? So the question here is z value, that is z square minus 2z. So this is z square minus 2z by z plus 1 square into this is z square plus 1. See from the question. So this is f of z value. So z plus 1 square and z plus 1 square got cancelled. And what remained here? So this will be 1 by 2 minus 1 factorial is nothing but 1 by 1 factorial into this value is limit z tends to minus 1, and this is d by dz times of z square minus 2z by this value is z square plus 1. So I have to make a derivative. So this is of the form u by v rule. So for finding the derivative of u by v, so if I consider this as u and this as v, and the derivative will be, so the derivative will be, so we have to make v square. So we have to again leave v, we have to make a derivative for u, and again we have to leave u, and again we have to make a derivative for v. So this is the thing which we have to do now. So I have to consider this as u by v rule. So this will be 1 by 1 factorial is again 1. So this will become limit z tends to minus 1, and the derivative I am making here. So this is u and this is v. So v you have to make a square, that is z square plus 1 whole square, and again I have to leave v, that is z square plus 1 I'm leaving, and again I have to make a derivative for u. The derivative for u is, this is 2z minus 2 minus, what is u here, this is z square minus 2z, and for, see here, v dash, so this is v, and we have to make a derivative which is nothing but 2z. See here, after making derivative, we have to substitute the value as z as minus 1. See here, if I put z as minus 1, this will be plus 1, and again this is plus 1. So if I keep minus 1 here, this will be minus 2 minus 2 minus, if I keep minus 1 here, this will be plus 1, this is again plus 2, and this is again minus 2 by, this is minus 1 square is nothing but 1 plus 1 whole square. So this value here is, I'll show you, this is 2 into this value is minus 4, this is 3, and this value is 2 by, this is 2 plus 2, this value is 4, 2 square value is 4, this value is minus 8 plus 6 by 4, which is equal to minus 2 by 4. So the value here is minus 1 by 2 is the answer. So this is minus 1 by 2 is the answer for the residue of f of z at point z is equal to minus 1. So here the first pole here we got as z is equal to minus 1, which is of order 2. So order 2 means m value is equal to 2 and the pole value here is minus 1. After substituting in this formula, we have to make a derivative for one time, and this is of u by v rule, and here the derivative here is v square by vu dash minus uv dash, and after applying in the formulae, we have to substitute the z value, the limit value, the z value as minus 1, and after substituting we got the value as minus half. And the next one here, the simple pole is I. So z is equal to I. So if I substitute here for z is equal to I, which is a simple pole, for z is equal to I, the residue of the function at z is equal to I is nothing but, this is z minus I into f of z. So this value is z minus I into, what is our f of z value? F of z value here is this one, that is z square minus 2z by, this is z plus 1 square into z minus I into, this value is z plus I. So if I cancel this z minus I, so what remains here? So we have to apply the limit value as z is equal to positive I. So after applying, so here also limit z tends to I, z minus I into f of z. So we have to apply the value of z as I here, z square minus 2z by, this value is z plus 1 square into, this is z plus I. So if I keep z value as I, so this will be I square minus 2 into I by, this is I plus 1 square into, this value is I plus I. So as you know that I square value is always minus 1. So as you know this value, that is I square value is equal to minus 1. So if I substitute I square value as minus 1, so this is minus 1 minus 2i. So this value is nothing but I square plus 1 square plus, this is 2i into, this is I plus I, which is equal to 2i. So here this is minus 1 minus 2i. I square value is again minus 1. This is plus 1 plus 2i into, again this is 2i. If I cancel minus and plus, so here this will be minus 1 minus 2i by 2 2s are 4, and again this is I square. I square value is again minus 1. So if I take minus as common and if I cancel, so the answer will be 1 plus 2i by 4 is the residue value of f of z at simple pole z is equal to I. Clear? And the next thing here is, and the next pole here is z is equal to minus I. For z is equal to minus I, see what I will do here. The residue value for z is equal to minus I. Residue of f of z at z is equal to minus I is nothing but, limit z tends to minus I, this value will be z plus I. See here, this will be z plus I into f of z. Clear? And here this will be limit z tends to minus I, this is z plus I into, what is the f of z value here? F of z value is nothing but, this value is nothing but z square minus 2z by this value is z plus 1 square into this is z minus 1 and this value is z plus 1. So if I cancel this z plus 1 and substitute z value as minus I, so this will be minus I square minus 2 into this value is minus I. In place of z I have to substitute minus 1. This is plus 1 whole square and this is minus 1 into minus 1. So minus 1 square is nothing but positive square, that is I square, which is equal to minus 1. This is minus of minus plus 2I by, if I expand this one as a plus b whole square, so this will be a square plus b square and this is minus 2ab. See clear? Minus 2 into a into b into, so this is minus 2I. So here the value here is minus 1 plus 2I by I square. So which is equal to minus 1 plus 1 minus 2I into this value is minus 2I. So after cancelling these two, so this will be minus 1 plus 2I by minus into minus plus 2 2 is a 4 and again I square. So I square value is again minus 1. So this will be minus. So if I take minus common, so this will be minus 1 minus 2a by minus 4. So if I cancel this minus here, so this is 1 minus 2a by 4. This is the residue value of f of z at point z is equal to minus 1. So this is how we have to solve. This is also so simple if you follow these steps. And here is the formula, which is so simple. First thing what I have done is, first one, this is the function given, so we have to equate the denominator to 0, and after equating denominator to 0, so we got the poles as z is equal to minus 1 is a pole of order 2 and z is equal to plus I is a simple pole and z is equal to minus I is also a simple pole. So first of all, which is of order 2, so here is the formula, that is 1 by m minus 1 factorial into z minus z naught into d by dz power m minus 1 into z minus z naught power m into f of z. So here our m value is equal to 2 and z naught value is equal to minus 1. After substituting, we have to make a derivative for one time. So the derivative is also of u by v rule, and this is v square by v u dash minus u v dash. So after substituting in the formula and after replacing z value as minus 1, so we got the residue of z is equal to minus 1 as minus half. And the next pole here is z is equal to I. So for z is equal to I also, the residue at z is equal to I is nothing but limit z tends to z naught, z minus z naught into f of z. So here z minus I, f of z value is this one, and after cancelling z minus I and after substituting z, as it is a simple pole, there is no derivative here, we have to directly substitute z value as I, and after calculating the residue value of f of z at point z is equal to I is this one. And next one, the simple pole is z is equal to minus I. And again, this is also limit z tends to z naught, z minus z naught into f of z is the formula. And if I keep z naught value as minus 1 and cancelling numerator and denominator from the function, and after substituting z value as minus 1 and after calculating, we got the residue value as 1 minus 2I by 4. And this is how we have to solve. This is the most important question, repeatedly asked question. If you really understand, please practice for one more time and definitely you can score more and pass it on to your friends.